All right, welcome back, everybody. This is going to be a two-part lesson. There's going to be 3.2a and a 3.2b because we're splitting up some concepts. So this one's going to be about solving quadratics by factoring when a is equal to 1. And you have two objectives: to solve quadratics by using the factoring method where a is equal to 1, and to use the diamond method to find the correct factors. Okay, so this is going to be focusing a lot on greatest common factor and a is equal to 1. And then part B will be on where a does not equal 1. So first we have a little bit of math talk, right? Can we go from two binomials back to their trinomials, okay? Now to review that, right, we have a binomial times a binomial, so x plus 2 times x plus 4. We know this is actually a quadratic here that's broken down into its factors. So let's unravel it, right? And you guys know how to do this, right? You take your first, term, you multiply it by the next two, you end up with x squared plus 4x, and then you take 2 times x and 2 times 4, you get plus 2x plus 8. It should all be pretty straightforward. You simplify, and you get x squared plus 6x plus 8, okay? So notice how we went from a binomial times a binomial to a trinomial. Those are both the same exact quadratic. There's nothing different about those quadratics, okay? But what we want to do in this lesson is we want to start from this trinomial and go back to the binomial times a binomial, okay? So we're looking at this reverse order. The only difference is we will not have seen these first, okay? And so it often is asking the question a lot, what two terms did we add together to get here, right? What were these numbers equals? All right, so let's dive into that exact example of how do we actually do this. So first, this method is solved by factoring. So the process of finding the expressions that multiplied together to make the quadratic. That's why we call it factoring. We're trying to figure out how to break this trinomial down into the factors that we multiplied to get there, okay? The way we do this is first we identify if it's in standard form, which this is, right? We have an a, b, c. So you have your a value of 1, your b value of 6, your c value of 8. All right, so there's no number there, okay? And then we use the diamond method, or what you're going to hear me call it a lot is the x factor. I just like to call it that way. I don't think anyone else does, okay? And the way we do that is we take our a times c variable up top and our b variable on the bottom. So a is 1, c is 8, so we have an 8 up top. B is 6, okay? And then we ask ourselves a simple question. We go, what number could go here and here that if I multiply them, I get 8. And if I add them, I get 6. So two numbers that multiply to get 8 that add to get 6, okay? So when I look at this, you got to run through the factors, right? Well, I know that 8 times 1 is 8, but 8 plus 1 is 9, so that's not it, right? And then 2 times 4 is 8, and 2 plus 4 is 6. So I know that 2 and 4 go there. Now think about that for a second here. 2 times 4 is 8. 2 times 4 is 6. Well, this trinomial originated from this. And now look at these numbers. 2 and 4. When you did a binomial times a binomial, you had to multiply these numbers together to get 8. And then when they were in their term with x, so 2 times x and x times 4, you had to add them to get your b, right? So you multiply these numbers to get c. You ended up adding those numbers to get b. That's why the x factor is this way. We're asking, what did we multiply to get our c value? And what did we add to get our b value? So this is a reverse order. So now when a is equal to 1, you can jump from this to your answer. You can say x plus 2 times x plus 4, okay? This would have been it broken down, okay? Now we do need to take it a step further than this though, right? We need to actually find what x is equal to. That is your, quote unquote, your zeros or your x-intercepts. And so we make it equal to 0 and we go x plus 2 times x plus 4, okay? And now we know something about this, all right? And this is, I think, another cool part about math, all right? If we know that by taking this times this, then my answer is going to be 0. Well, then one of those has to be 0, right? When you think about that, because the only thing you can multiply together to get 0 is if one of your factors is 0. You can't go 3 times an actual number that's not 0 and get 0. So let's play, kind of a guessing game. Let's assume one of them is equal to 0 and then find out what the other one is. So let's assume this is 0 first, okay? Which means then we really have 0 is equal to x plus 4. You solve for x, you minus 4, you minus 4. You get x is equal to negative 4, okay? Now let's do it again. Let's assume that this one is 0. So we get x plus 2 is equal to 0. You solve for x, and you get x is equal to negative 2. So you have 2 answers, okay? You have x equals negative 2, and you have x equals negative 4, okay? So this would be going backwards and then finding out what x is equal to, okay? And we do this with the diamond method. Now we're going to do a lot more examples if you're confused at this point, okay? But I want you to understand something. We are trying to go backwards, essentially. You're probably more used to doing this step at this point. This is something you would have seen a lot by now. And you ended up here. Well, how do I go from here back to this, okay? All right, so we're going to jump into another review because we're going to look at another method of solving by factoring, okay? We're going to talk about the greatest common factor, okay? Now, the definition's in the wrong place, okay? All right, so the greatest common factor is the highest number that divides exactly into 2 or more numbers. Now let's look at what that exactly is. Here we have a binomial, 28x squared minus 8, okay? In order to do this, in order to take out the greatest common factor, we look at both terms. We look at this term and this term, and we ask ourselves, what's the biggest number that can come out of both of those? Start by looking at your smaller number. Start by looking at 8, because we can't get any larger than 8. So I know 8 goes into 8, but 28 does not go in, or 8 does not go into 28. So I look at the next biggest number. I look at 4 goes into 8. That's the next biggest. 4 does go into 28. So I'm going to divide 4, which would be our greatest common factor, out of both of these. So 24 divided by 8 is 7. We're left with the x squared minus 8 divided by 4 is 2. And then we would leave this on the outside normally, okay? But if I was just asking what the GCF was, the answer would be 4. Now this is going to be very helpful for the other way, where we don't need to use the diamond method to factor, okay? So let's look at the next one, 16 and 8. Well, I know that 8 goes into both of those, right? 8 goes into 16, 8 goes into 8. I can't get any higher than 8, but I also have a variable in both of them. Now, when you divide out variables, if you remember those properties, you just end up subtracting. If I take x to the power of 3 divided by x to the power of 2, this is the same thing as x to the power of 3 minus 2, or a. So we cannot divide out a larger exponent, okay? And what I mean by that is, for a to the power of 2, we cannot have a greatest common factor that is bigger than that, just like we cannot have a greatest common factor that's bigger than 8, because it's the smallest number. So it's the same thing here, and it's a little bit easier with variables. You can actually just kind of look at the variable and go, well, that's the biggest thing that goes into itself, and that's the biggest thing that goes into a to the power of 3. So our answer here for the greatest common factor would be 8a squared. All right, so I'm going to put that on the outside. We'll call that our GCF, 8a squared, and I divide it out. 16 divided by 8 is 2. And then I do the subtraction, right? A to the power of 3 divided by a to the power of 2 is a to the power of 1. And then a to the power of 2 divided by a to the power of 2, if I were to subtract those exponents, I get 0, so it's gone. 8 divided by 8 is 1, and that's what I would have left. You could see that we kind of factored in a way here. We broke things down into something that we multiplied back together to get to the original. Now, if there's 3 terms, it's the same thing. 3 is my smallest number, and 3 goes into 9, it goes into 27, and then I look, y is my lowest y, right? So that has to be my greatest common factor. Has to be 3y. And then I could divide that out. And I end up with 3y times 9y squared minus y plus 3. Notice how a single y got subtracted out of all of those because we were dividing by y. All right. Now, this is another way kind of factoring with quadratics, and we only really use it in certain situations. This is the situation that I would use this for. Notice how there's no c term, okay? And there's an x in both. So I have my a term and I have my b term. I could use the diamond method here if I wanted to, or I could factor out the greatest common factor and still get to an answer. So look, 4, 16, that's perfect. 4 goes into 4, 4 goes into 16. So I know my GCF is going to have a 4 in it. And then I look at the x. It's the smallest variable, so I know it goes into x squared. So my greatest common factor is 4x. Okay, I'm going to divide this out. Just like that. And I'm going to end up with, let's put the 4x on the outside. 4 divided by 4 is 1. X squared divided by x is just x. And then negative 16 over 4 is minus 4. And there's no more x because they cancel out. And I'm left with this. But this is f of x is equal to that. Now, let's jump back just really quickly here. Let's jump back. When you factored this quadratic, we ended up with x's that were not squared or anything like that, right? Just, a binomial with x and a binomial with x, and we're easily able to set it equal to 0 and find out what x is equal to. Well, if we could do that by simpler methods, why not? Look at here. We have 4x, right, which is a factor. And we have x minus 4, so set it equal to 0. And then again, assume one of those is 0, right? Because that's the only way we could get to 0 with multiplying. So I'm going to assume that this one is 0 first, okay? So that means we have 4x equals 0. Well, you divide by 4, you divide by 4. And so one of your answers is x equals 0. And you're going to see that a lot when you have that monomial there. And then I'm going to do it again, but I'm going to assume 4x is 0. So that means I have x minus 4 is equal to 0. I add 4, I add 4. I get x is 4. 2 answers, okay? Now, we could have done the diamond method, believe it or not. A times c, well, c is 0. You get a 0 on the top, right? And then on the bottom, you end up with a b of negative 16, and you ask yourself, what times what is 0? That gives me 16. And, there's a lot of different things that we could have done there, right? Like negative 16 and 0. You would have gotten to the same answers, but let's not do this, okay? If you see that you can just factor out a greatest common factor, it will be the simplest method. So do that one, okay? All right. So a lot of warm up there, right? A lot of math talk, a lot of just diving into concepts. So let's do some problems, okay? Here we have one where you have x squared minus 9a. I think the next one's for you guys too. We have x squared minus 9x plus 18, and we're just going to go through. We're going to do this with the diamond method. All right, I see that we have a c term, so we need to do it. We have an a, we have a b, we have a c. We write it out. A times c goes up top, b goes on the bottom. So 1 times 18, or just 18, and negative 9. So I have to ask myself, what two numbers can I multiply to be 18 and then add those to be negative 9? If I try 18 and 1, it doesn't work. Look at this. I know that 6 and 3 give me 18, right? Now, when you look at 6 plus 3, that's positive 9. So that's not correct, right? Because it has to get to negative 9. But I can just make a simple switch, a negative and a negative. Negative 6 times negative 3 is positive 18. Negative 6 plus negative 3 is negative 9. So because a is equal to 1, I can write this out. X minus 6 times x minus 3. Okay? Now we set this equal to 0, and then you cover 1. So x minus 6 is equal to 0 is 1, and x minus 3 is equal to 0 is the other. You add 6, you get x is equal to 6. You add 3, you get x is equal to 3. Boom and boom. Those are your two answers, okay? Now notice, kind of before I give you one to do, right? You could not have used solve by square root for any of these, okay? And that's a key idea here. There is a time and a place to use one of these methods, all right? Now, here's one for you guys to do. Give it a pause, give it a try. Okay, so hopefully you gave this a try. You do your X factor or your diamond method. A times C goes up top to be 4. B goes on the bottom to be 5. What times what gives you 4? That adds to be 5. The answers would be 4 and 1. 4 plus 1 is 5. 4 times 1 is 4. So I can go 0 is equal to x plus 4 times x plus 1. Okay. All right. Now, I have two equations. Right? I got to set 1 to be 0, so x plus 4 is equal to 0. And then x plus 1 is equal to 0. I minus the 4, I minus the 4. I get x is equal to negative 4. I minus the 1, I minus the 1, I get x is equal to negative 1. So here are my two answers, those are your x-intercepts, right? If you were to sketch these, they would need to go through this, okay?